So here again we have another question. We have the limit of x plus x turn v plus l'infini of 1 over x squared plus 1 is equal to 0. As you can see, it's normally at the beginning we had x turn v x is 0 and then a certain limit. At the second part we had x turn v plus l'infini and then limit infinity. That's where we had the limit infini con x turn v l'infini in the previous video. And now in this case we're having x turn v plus l'infini and then to a certain limit, and we have this as our f of x. So if you have something in this form, limit of f of x, and then put f of x equal to a certain limit L, you see we have 0 when x turn v plus l'infini. This is the formula that we apply, that for every epsilon greater than 0, there exists and b greater than 0, tel que x greater than b implique, that's this, implique that f of x minus L will be less than epsilon. So you can put this definition down. So for this question, I wrote here that for every epsilon greater than 0, it will exist and b greater than 0, such that x greater than b implique that 1 over x squared plus 1 is less than epsilon. This, I put it 1 over x squared plus 1. Why? Because L is 0. So even if I subtract it with 0, I will still get 1 over x squared plus 1. So I just left it as 1 over x squared plus 1 less than epsilon. Just like we've always been doing, we have that 1 over x squared plus 1. We have that, right? I know that 1 over x squared is less than 1 over x squared plus 1, just like we've been doing. And you pick a number that can either be greater than the previous one or that can be less than the previous one. But in this case, it's better to pick a number that is less than the previous number in what we've done. So to have 1 over x squared plus 1 less than epsilon, okay, so in order to, because to have a, like, yes, exactly, you got it, instead of having 1 over x squared plus 1 less than epsilon, we can have instead 1 over x squared less than epsilon. So yeah, so we'll put that down. So we'll have 1 over x squared less than epsilon. And what are we looking for? We're looking for x greater than b, just like. That's why the definitions are very important. Always use it because they help you to find what you're looking for. But I have it 1 over x squared inferior epsilon, and I'm looking for x squared. So what do? I inverse. And when I do that, this will change, the inequality sign will change, epsilon will also change. Because if I have x squared, 1 over x squared is less than epsilon, but x squared is greater than 1 over epsilon. I put this, then I change the inequality sign and switch this as well. So I have to apply that to all of them so I can get my x. So now I'm looking for what's b. So what can I do? I can have x greater than la racine de 1 sur epsilon. Racine de 1, c'est 1. That is square root of 1 is 1. And then racine de epsilon. So I can take b, because this is now in what form? This is in the form of x greater than 1 over racine de epsilon. So I can take b, this b, to be equal to 1 over racine de epsilon. Donc, on choisit alors b égale à 1 sur racine de epsilon. And that's what we're supposed to prove. That's your final answer. So finally we have b equal to 1 over racine de epsilon. See you in the next video. Thank you.